Okay, welcome back. So I wanted to do an example that would bring the mean value theorem to life. Many students sort of recite the mean value theorem, but they want to see it in action. They need to draw it, and that'll help them understand. So for starters, you know that you can recite the mean value theorem, which basically says if your function is continuous over the closed interval from a to b, here our closed interval is -1 to 1, then there must exist a point C such that f prime of C is equal to this lovely quantity here, f of b minus f of a over b minus a. And like I said, reciting that is one thing, and doing the mechanics of that is another thing, and then seeing it. So we want to tie it all together, okay? So for starters, find the value or values of C that satisfy the equation f of b minus f of a over b minus a is equal to f prime of C in the conclusion of the mean value theorem. So initially in a first level calc class, I don't know that reciting the mean value theorem is as important as performing the mechanics of it and then understanding the visual, the geometry behind it. So we have a function. It's definitely continuous over this closed interval. Let's first find the derivative, okay? It says find the values of C that satisfy this equation. And I have the answer. The value of C ends up being 0, but I want to show you that, okay? So let's start with f prime of x. So that's going to be 10x minus 2. And then, of course, that's lowercase f. F prime of c then will be 10c minus 2. And remember that the mean value theorem tells us that there must exist some point c in the interval from -1 such that this must hold true. All right. Well, now let's look at f of b minus f of a over b minus a. Well, the denominator of that will be easy, right? So remember that when you say from -1 to 1, remember that this is your a and this is your b. So you have basically 1 minus minus 1, which will eventually come to be 2, right? In the numerator, f of b minus f of a, that basically means, I'll do this in another color, you have to take your b, store it in to the function, crunch it out, get some output. So, 5 times 1 squared is 5, and 2 times 1 is 2, so 5 minus 2 is 3, and 3 minus 3 is 0. So I'm just going to lead you to investigate that f of b will come to be 0. Then try f of a, function evaluated at a. Okay, now let's take -1, store that into the original function. -1 squared is 1 times 5 is 5. And you have to be really careful of your signs. -1 times -2 is +2. So you have 5 plus 2, which is 7, minus 3, which is 4. So the overall number crunching on that, I'm going to let you deal with. I think you're comfortable with that by now. So 0 minus 4 is -4. So after all that sweat equity, we are arriving at -2. Aha, but what was -2? Remember that is just this side of the equation. So let me zoom in on that, if it'll let me here. Let me see. Okay, so now I'm even going to do this in another color. So all that part came to be -2. And f prime of c is this part right here. So you're using some algebra. You're going to solve for c. So 10c minus 2 must come to be -2. I'm going to zoom out again. Now you just use some algebra, solve for c, add 2 to the other side. So now we have 0 equals 10c, therefore c must be 0. Oops. Okay, now that answers that part of the question. Remember, I had typed that in. It said find values of c such that satisfy the equation. So fine, we found it. But now what does this mean visually? So after all that, notice I took a little snapshot of my graphing calculator here. So after all that, what does that mean? So in words, that means that the slope of the tangent line at C, and I'm even going to, and what was C? It ended up being 0. So let me draw this in here. So slope of the tangent, here I am on my curve. So notice I graphed the original function. All right, I'm going to sketch in the tangent line. And whatever the slope of the tangent line is, the mean value theorem guarantees me, so f prime evaluated at C, that means slope of the tangent line at C, has to be equal to, and that basically means slope of the secant line that passes through AB. All right, well, here's negative, you can see negative 1, 4, and then the other point was at 1, 0. So if I sketch in a secant line here, what basically the mean value theorem does, note to self, here's a secant line, here's a tangent line. It guarantees us that those lines are parallel. So basically a geometric perspective there is that f prime of C, which is the slope of the tangent line at C, is equal to the slope of the secant line that passes through, that passes through those points with regard to AB. Okay, so again, visually, that if I were to take that key point, negative 1, 4, and the other key point, 1, 0, based off of the interval that was given, like I said, pass a secant line through it, whatever the slope of that secant line is, it's the same as the slope of the tangent line at 0. All right, hope that helps. I just wanted to give you, like I said, a geometric perspective on, and I'm zooming back out here, so you can see how we solve for C equal to 0. Again, that's just a geometric perspective. In another podcast, I want to do more of a word problem perspective on the mean value theorem. Okay, good luck out there.